Alright, so I have three problems here. The first one's function notation, the next two are limits. Alright? First one says f of x is a root function that's shifted to the right 3. The second one is a parabola, right, that's shifted right 1, down 1. And it gives me f of g of x. Well, f of g of x just means put in g of x into f of x. And the easiest way, I'll write it unsimplified, is we're putting this in there. Do you guys agree? And often, when I'm given problems like this, I expect you to simplify it. The green is not an acceptable answer. Of course not, it's way too easy. So how about x squared minus 2x plus 1? So that would turn into this. The final answer should be that. When you expand the green, you'll get the blue. And that's the answer you need. Now, everybody, this whole problem comes back probably to a lot of pre-calc, but it's figuring out the domain. And there's two ways to do this, okay? The first way is to realize that x squared minus 2x minus 3 has to be equal or greater to 0. So you find the zeros and work it. I'm going to do it that way first, and then I'm going to show you another way. So I can say, hey, I know x squared minus 2x minus 3 has to be greater than or equal to 0. And the first thing I'll do is find the zeros. You guys agree? Now, quadratic formula works here, guys. Quadratic formula works here. And in all honesty, the best way to handle this problem, the one reason I wrote it in green, I'm not going to do the quadratic formula. I hate the quadratic formula. You guys agree the green underneath the radical is x minus 1 squared minus 1 minus 3? So I can write this as x minus 1 squared is greater than or equal to 4. Take the square root of both sides. And we know, all right, when we know when we take the square root of something like this, we get the positive case and we get the negative case, right? So it's plus or minus 2. I'd rather find the zeros and think about it. Often when I take square roots here, I just do this. I go x minus 1 is equal to plus or minus 2. Add 1 to both sides. So I find that the zeros are 3 and negative 1. Now, that means for the domain of this thing, there are 3 regions for us to think about. If I put this on a number line, I know these 2 points work, right, because it equals 0. So I'll put big blue dots. Guys, those 2 points are in our domain, guaranteed. Right? The question is the green, is the red, or is the black? So I'll just pick a value in each region. You guys agree the easiest one in the red is 0? If I plug 0 in here, guess what? The inside of the radical is negative. 0 does not work. I pick something in the black region, say 100, right? Because that's right of 3. Does 100 work? Absolutely 100 works, right? How about negative 100 on the other side? Absolutely that works. So our domain is negative infinity to negative 1 and 3 to positive infinity. I don't like this method. Most students do. I think this method is cumbersome and somewhat ugly. All right? I think the pretty way to do this problem is to understand what each function is doing. All right? And what I mean by that is, does everybody agree that f of x is that function right there? Right? Okay? Does everybody agree that g of x, 1 over, 1 down, that g of x, if I graph it, whoops, is a parabola. It looks like that, with a vertex of 1, negative 1 at the bottom, okay? That's the vertex. All right, here's what I know. I know that when I have f of g of x, that I am putting x into g of x, right? and that is creating an output, and that output goes into f of x, right? And that produces our final output of our resulting y. Guys, it's a combination of two machines, right? First machine does something, the second machine does something. Here's what I see. I know that the input to f of x has to be 3 or greater. You guys agree on for a value? The only input I can have into this function is 3 or greater. Well, what gives the input to that function? In this case, the output of this function is the input, right? So when I say, I know it has to be 3 or greater, I can see that 3 or greater is this portion of the curve of the parabola. And again, I still have to sit here and find the values, but the second when I picture this, guys, I don't have to do this region stuff, do I? Once I do the work, I know the outsides of the parabola provide our domain. This is a very hard one, but these are the ones in 1-3 too. You start going through the homework, okay? 1-3 has a lot more line ones, and again, that would be good practice for the test. Did anybody try to factor 2? You don't need to. Everybody, look, the bottom is not 0. That's all you got to know. And then what is the top? 0. 7 seconds of work. The answer is 0. Everybody, you plug 2 in the bottom, and you know it's not 0. It's 8 minus 12 plus 6. It's 2. The top is 0 times 9. The answer is 0. On the test, this has to take you less than 40 seconds. Any time wasted factoring this is a disaster. All right? Again, we only factor if it does not, if we only factor or expand or do anything when the bottom is 0, right? It drives us there. This one, 2 ways to do this one. The clean method is to recognize it as a reciprocal function. I just graphed 1 over x in blue, but this one is shifted 4 to the right. So I can move this curve right here. And when I do this, you should see it's negative infinity. If you can't picture that curve, then you are stuck. If you can't picture that curve, and it is negative infinity, we'll write that in. Then you are stuck working like doing the values like an XY table. And I start with 3.9, right, which is negative 10. And then I plug in 3.99, I get negative 100. Then I get 3.999, and I get negative 1,000. And at this point, you make the deduction because you know because this is going to be a vertical asymptote, right? That is going to approach infinity from our days of pre-calculus. That it's going to approach that value because it did not cancel. There was no x minus 4 in the numerator to make it go away. All right, so the answer to number 3 is negative infinity. Oh, how about this? I want you to create a graph with the following conditions. The limit as x approaches 0 from the right-hand side of f of x is negative 2. The limit as x approaches 0 from the left-hand side is 1. F of 0 is negative 1, and so on and so forth. All right? Everybody's graph will be different. All right? And I will give you a head start here. I'll pause the video, go ahead and make your graph, and then we'll do this one. So everybody, I'm gonna try to do this in different colors so we see what each part looks like, and then we'll connect them all. I'll do the first one in here in red. It says the limit as you approach 0 from the right-hand side of f of x is negative 2. Open circle. I'll just start a line to the right-hand side. I don't care how the line comes in. I'm gonna connect all these later. And then it says from the left-hand side it's equal to 1. All right, I'll do that. That's the blue, and then I'll do I'll do purple. F of 0 is negative 1. Boom. There's the first 3 limit conditions that I was told. Okay, I got to keep going. The limit as x approaches infinity equals 3. Guys, that's a horizontal asymptote. I guess I don't have to dot it when I'm holding the dotted line. I don't know if that comes from the top side or the bottom side yet, all right? But I put the asymptote in, and and it says the limit as x approaches negative 4. as negative infinity goes to 4. So on the negative infinity side, I have that line. All right, and I gotta do, and it gets better here. So hang on. Now I'll just guess. How about that? How about that? I don't know. You could put those arrows on the top side, guys. You could put this arrow here. It could be here. I'm just gonna put it here, okay? I don't have a reason yet. I might have to erase and move it. Of course, I have a smart board. I might have to move it to make it look pretty. But that's just as it goes out to infinity. So I'll just do that. Now the last one. I'm going to make the asymptote yellow. You guys see it says it goes to negative infinity and positive infinity at 2. The left hand and right hand. So at 2, guys, guess what I know for a fact? I know there's a vertical asymptote. I know there's a vertical asymptote because it goes to infinity on both sides. Now, what color haven't I used yet? I haven't used green. No, well, yes, I have. I haven't used black. So I'm going to do this one in black. As you come from the right-hand side, it goes to negative infinity. When you come from the left-hand side, it goes to, I'll do it in black too, it goes to positive infinity. Now I just, listen, when I grade, I check for all these marks. Okay? Now all you have to do is make it a function. So just make sure when you play dot to dot, you don't break the vertical line test. All right? So for my red dot, I just curve up. You know, there's that line. I just play dot to dot here, right? And this is one of a lot of answers. What I would grade, now this passes the vertical line test, right? This is a function. So that's your first thing I would grade. A couple points for that. But more importantly, what I would grade, and I'll start circling it in yellow. I don't know. Here we go. I would grade that you have this approaching the horizontal asymptote. I would grade that you have this asymptote. I would grade this asymptote and this asymptote, okay? Then I would grade these three things right there, right? You think about it, I just circled 7 conditions. 1, 2, 3, 4, 5, 6, 7. There's 7 conditions. And then you just got to play dot to dot. You just got to make a function out of these sets. All right? So, and again, how do you know there's, I know there's a vertical asymptote because of these 2 conditions right here, guys. And I think that's the one thing students often overlook. That's a vertical asymptote. That's the only way you go to infinity, guys. I guarantee what this function has in the denominator is x minus 2. Now, I don't know what this looks like. I have no idea how to make the rest. Could be a piecewise function, right? There's lots of chances. I made it continuous everywhere else. I suppose you could make the argument, Mr. Anderson, why do I have to make it continuous? I suppose you don't have to. You can put a hole here. That would still be right, right? You just add a condition at, 1, 2, 3, 4 and a half. You just at 4 and a half, you made the limit equal to negative 2. I don't know why you would do that, but you could. Just to make my life hard to grade, so I have to think about why you're doing it. But this is the best picture in this case that communicates these conditions. All right. Should we try one more like that? Yeah? All right. Let's copy this. Kind of waiting on Albany here. I'll put up some conditions. Limit as x approaches negative 1 of f of x is 3. I'll put one more in. Alright, so again, 1, 2, 3, 4, 5, 6, 7 conditions again to math, okay? And again, any set of graphs. I'll pause the video here, take a chance to do it, and I'll make mine then. Cheers. Alright, so you paused me, you did your drawing, here we go. I'm going to try to do each of the color, or at least one at a time. I'm going to start with this one. I'll put a red dot here. Limit as x approaches -1 of f of x equals 3. -1, 3. Boom, boom. I said the limit existed so that the lines have to come in both ways. And the next thing I had was f -1 equals 2. So I need a solid dot at 2. So everybody, those first two conditions should look like that on your graph. I don't know what the rest of your graph looks like. I don't care. The next thing I said, the limit as x approaches 4 is infinity. Guys, that means at 4, 1, 2, 3, 4, there is an asymptote. All right? And if I do this in green, there's the asymptote. Both hands are going to positive infinity because I said the limit exists. So the left hand and right hand both are positive infinity. It should look like that at 4. Then I said as it approaches infinity, it goes to 1. So again, I'll do, I haven't used blue yet, have I? I'll kind of draw an asymptote. I was looking for the curve to look something like this. It could, oh.
I like had it all the way across.
So you went across, that's fine. So you could, I don't care.
I mean, like I connected it. Yeah. No, it's like, does it just have to be on the right side? Or
Yeah.
just is that?
Yeah.
That's the only thing.
Well, and if you connect it all the way across, I'm not going to mark it wrong. I don't know what it does over here. It doesn't go both ways. I only said it which was positive thing, but I wouldn't mark it wrong if you had the dotted line the whole way across.
Okay, that's what I.
All right, but listen, I'm looking for the blue curve. I don't even need the dotted lines, guys. I'm looking for the blue, the green, and the red. I am not looking for the purple. Then it says the limit as x approaches 2. Let's go back to, what color? Black. We haven't used black. Limit as x approaches 2 from the positive side is 3. So 2 from the positive side is 3. And 2 from the negative side is -1. I'm going to have to do some different, I'm going to have to erase and make some things here, okay? And f of 2 is -1. Also, that fills in. And now, I'll use my yellow pen to say, okay, I'll make it a function. All right? And I might have to erase a little bit of that green. And this is one possible answer, guys. But I am grading the red, the black, the green, the blue. And then I say, hey, did you make a function on it? Now, everybody, I want to be clear about this. I'm going to change this horizontal asymptote because it doesn't have to look this way. You can make it look this way, and I'll do it in blue the whole way. Right? It could approach 1. It could duck over the asymptote and then approach 1 like that. It could, you could draw it, again, like this. Right? That still approaches 1, right? I am not the graph police. I didn't tell you what it should look like in this area here where I circled. It can look like almost anything. Again, my comment is, really, do you maybe think it should be easy? But whatever. You know, and this meets the limit conditions, guys. So these 3 are the blacks at the bottom, right? Right here. Filled it, open filled. The blue is right here. The green is right up here, those 2. And the red is those 2. The yellow just makes a function between those conditions I set. Does that kind of get you guys pushed in the right direction? And I love these. I think this is a great way to quiz you on about 10 concepts, right, or 7. Line them up and make sure you understand what that means. Boy, I'm dragging my feet for Albany. Got one more. Find the equation of the tangent line. I'm missing articles. Find the equation of the tangent line of the function g of x at x equals 2. And I made g of x equal 4 minus 3x squared plus 2x. Hey guys, don't do the definition of derivative. Don't do that. I think this lends itself to the power rule. You guys agree? I mean, I should be able to find the derivative, g prime, in 2 seconds. All right, give you a push. So, again, you have to remember a couple facts here. One, if you're going to make the equation of a line, you need a point and a slope. I give you the x-coordinate, so maybe the first thing I do is I want to know what y equals at 2. You guys agree? So I do g of 2 equals 4 minus 3 times 2 squared plus 2 times 2. I get -4. So everybody, my point is 2, -4. That's the point of on the function g of x. Now I need the slope. Well, the slope comes from the derivative. So I just do g prime of x. Derivative of 4 is 0. Derivative of -3x squared is -6x. Derivative of 2x is 2. I need the slope at 2, so I plug in 2 for x. And I get it's -10. All right, Juda, point slope form. I know you guys aren't good at it. All right. If m is the slope, okay, and x naught, y naught is the point, the general form is y minus y naught equals m times x minus x naught. Our equation this time is m is equal to -10. The point was 2, -4. So how about y minus 4 plus 4 equals -10 times x minus 2. Equation of the tangent line at x equals 2. Yes, ma'am?
You just froze for like a minute.
Oh, really?
Yeah.
All right, well, I recorded this. I'm going to stop the video.
It's no, just how did you